Hello, welcome to Reaching for the Moon, hosted by me, Ed Grace. For those of you that don't know me, I worked on the Apollo program for 10 years at the MIT Instrumentation Laboratory located in Cambridge, Massachusetts, and it was later renamed the Draper Laboratory. MIT had a contract with NASA to design and develop the primary guidance, navigation, and control system, which was used on the Apollo command and lunar modules. The primary guidance, navigation, and control system included the Apollo guidance computer. I was a member of the Apollo 13 mission operations team that was awarded the Presidential Medal of Freedom for safely getting the astronauts on Apollo 13 back to Earth after an oxygen tank exploded in their service module on the way to the moon, leaving them approximately 200,000 miles away. In part one of this Artemis video series, I discussed the strategic and philosophical differences between the Artemis and Apollo programs. This video is part two of a 5-part series, and let's start today's discussion by comparing the differences in the launch rockets used by Artemis and the Apollo moon mission programs to get to space. Shown now is an artist's concept of Artemis I on the mobile launcher. Artemis I, which will be the first integrated flight of SLS and the Orion spacecraft, uses the SLS Block I configuration, which stands 322 feet tall and weighs 5.75 million pounds. SLS will produce 8.8 million pounds of maximum thrust. The Saturn V rocket, which was used on Apollo, was taller, 363 feet. It weighed 6.2 million pounds and produced 7.6 million pounds of maximum thrust. The SLS weighs about 8% less and provides about 15% more thrust than the Apollo Saturn V rocket. The SLS is certainly an improvement over the Saturn V. However, considering the Saturn V was developed more than 50 years ago, the performance enhancement is not as much as might surely be expected. However, our government's lack of interest in space exploration since the end of Apollo until about 10 years ago when private industry got involved is certainly a reason for this lack of rocketry advancement over this time period. To fulfill America's future needs for deep space missions, the SLS being used on Artemis is now being designed in stages, with major improvements occurring in each stage. The SLS Block I vehicle can send approximately 60,000 pounds of payload to orbits around the moon and beyond. It will be powered by twin 5-segment solid rocket boosters and 4 RS-25 liquid propellant engines. After liftoff and reaching Earth orbit, Artemis's interim cryogenic propulsion stage will be used to send the Artemis spacecraft named Orion onto the moon. On the screen now is a graphic of the components that make up the SLS Block I system. 2 solid rocket boosters, 4 RS-25 engines, the core stage, interim cryogenic propulsion stage, and the Orion multi-purpose crew vehicle. The first 3 Artemis missions will use a Block I rocket with the interim cryogenic propulsion stage. This graphic shows the planned evolution of the SLS Block I through the Block II. The Block I crew vehicle will use a new, more powerful exploration upper stage to power the Orion on its trip to the moon and enable more ambitious missions. The Block 1B vehicle can, in a single launch, carry the Orion crew vehicle along with large cargoes of up to 83,000 pounds for exploration systems needed to support a sustained presence on the moon. The next SLS configuration, Block II, will provide 9.5 million pounds of thrust. The Block II will grow to 365 feet tall, or 2 feet taller than the old Saturn V. SLS Block II will be designed to lift more than 100,000 pounds to deep space. Note, the payload increase from Block I to Block II, 60,000 pounds to more than 100,000 pounds, is quite significant. It's an increase of almost 70%. By making SLS an evolvable program, NASA has a rocket that it will be able to use to pioneer many new human space flight adventures. The SLS will become a workhorse for NASA to provide transportation to the moon, Mars, and other destinations for many years to come. Apollo's command module had a service module attached to it from launch until just before Earth atmosphere re-entry. The service module contained the spacecraft's main propulsion engine, which was also used to slow the command module and put it into an orbit around the moon, as well as being used to send the command module on its homeward journey from the moon. The service module also served as a storehouse of critical subsystems that provided a major portion of the electrical power and environmental control systems needed by the astronauts during their mission. Well, that concludes today's video. In the next video, which will be part 3 of our Artemis compared to Apollo series, I will discuss the Artemis Orion spacecraft and how it differs from the Apollo command module. If you like today's video, give us a like. Hit the subscribe button. Get notified by YouTube every time Reaching for the Moon posts a new video. Thank you for watching, and remember always, failure is not an option.